Dear students, welcome to today's lecture. Today we will verify Ohm's law theoretically as well as experimentally through simulations. Let's proceed to our lecture. Let's start with defining the Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Ohm's law can also be defined as the electric current is proportional to voltage and inversely proportional to the resistance. What it means is that the Ohm's law is defining the relationship of current and voltage. It defines that the voltage is in direct proportion to the current. As far as we are increasing the voltage, the current will also increases. Whereas the scenario of current and resistance is opposite. That is, if the resistance has a high value, the current drop across the specific resistor will be low, while if value of resistor is low, then the current drop across it will be high. Ohm's principal discovery was that the amount of electric current through a metal conductor in a circuit is directly proportional to the voltage impressed across it for any given temperature. As evident from the text that for a given temperature, the value of current will be in direct proportional to that of voltage. However, resistance will be kept constant. Ohm expressed his discovery in the form of a simple equation describing how voltage, current, and resistance may interrelate. The equation of Ohm's law is as follows. V is equal to IR. Here V is voltage, I is the current, and R is the resistance. If we remove resistance, then the relationship is direct. V is directly proportional to I. It can also be written in the form of resistance and current. In the form of current, it will be written as I is equal to V divided by R, and in the form of resistance, the Ohm's law will be written as V divided by I. Let's take an example of a simple circuit to understand the Ohm's law. We are going to consider the given circuit. Here we have a battery connected to a lamp. The battery is source, while lamp will act as a resistance. Current will be flowing through entire circuit, and we are going to take the direction of current in clockwise direction. As already conveyed, there is only one source of voltage, which will be our V, and only one source of resistance, which is the electric lamp or bulb. This circuit is very easy to be implemented and verify Ohm's law. If we know the value of any two of the three quantities, that is voltage, current, and resistance, we can use Ohm's law to determine the third. Now, in case if we are knowing only two values, either voltage, resistance, or current, we can find the third one. In the first case, we will calculate the amount of current in circuit given that the values of voltage and resistance are known. Here we have 12 volts as source, current is unknown, and resistance or lamp is 3 ohms. As already mentioned, we take the direction of current in clockwise. So we can find the current as I is equal to E divided by R. Here let me tell you that you don't need to be confused in terms E or V. Both are used for mentioning voltage. So I is equal to V divided by R. We have 12 divided by 3 ohms. Our current is 4 ampere. In the second case, we will calculate the amount of resistance in a circuit given the values of voltage and current are known. Now considering this circuit, we have 36 volts as our source, 4 ampere as our current, and now we don't know the resistance of the lamp. So we will calculate the resistance as R is equal to V divided by I. So 36 divided by 4, we get our resistance as 9 ohm. Now there is a third scenario where we are given with current and resistance of the lamp, but we have to calculate the voltage. You are advised to take up the scenario and do it yourself. It will also be included in your home task. Let's move forward to the Ohm's Law Triangle. Ohm's Law is very simple and useful tool for analyzing the electric circuits. A trick to remember for solving the Ohm's Law is Ohm's Law Triangle. First, we have to arrange the letters E or V, I and R in a triangle like this. We draw a triangle and made its 3 portions. At the first portion, we mention V or E, second I, and third is resistor. Now, if you know E and I and you wish to determine R, you just need to eliminate R from the picture and see what is left. You will be left with E and I. So now you can calculate R is equal to E divided by I. It's very simple. Now if you know E and R and wish to determine I, then eliminate I and see what's left in the triangle. You will be left with E and R. So now we can calculate I as I is equal to E divided by R. Lastly, if you know I and R and wish to determine E, you have to eliminate E from this triangle and see what's left. You will be left with I and R. So V is equal to IR will be the formula through which you can calculate the voltage. See, this is how you calculate different parameters, either E, I or R, through Ohm's Law Triangle. Let's move to our example. Consider the given circuit. Here we have 4 resistors connected to a supply. We need to take the supply as variable. That is, we can adjust the voltages from 0 volts to 10 volts. We have 4 resistances: 6 ohm, 8 ohm, 4 ohm and 12 ohm. Now there are 2 methods to go for solving this circuit to verify Ohm's law. First method is verifying Ohm's law for each of the resistor. And the second method is to verify Ohm's law for the R equivalent. In both of the cases, we will get a straight line for voltage and current. However, if we choose to verify Ohm's law for individual resistances, then we need to calculate voltages and current drops for all the resistors for different intervals of voltages, that is 2 volts, 4, 6, 8 and 10 volts respectively. And then we draw graph for each of the resistor and put it on the graph to verify whether the curve is straight or not. But in this lab we will go with the second method for verifying the Ohm's law of this circuit in terms of R equivalent. After simplifying the circuit for R equivalent, we get the following circuit. We get the resistance to be 12 ohm. As you know that these two resistors are connected in series, so its R equivalent dash will be 12 ohm. This will be in parallel with this resistor of 12 ohm. So here we will get 6 ohms. Now when 6 ohms is added together with 6 ohm, we get 12 ohm. So this is the final circuit for which we will verify the Ohm's law. We will apply voltages from 2 volts till 10 volts and see the current drop for this equivalent resistance. Opening an Excel sheet, we write voltages in the first column, that is 2 volt, 4 volt, 6 volt, 8 volt and 10 volts respectively. And in the second column, we write our resistance, which is 12 ohm, as constant. Now we can calculate current as I is equal to V divided by R. So we calculate V divided by R and we drag it down and then we place it through values. So here we have the respective currents. For 2 volts we have current drop of 0.17 milliampere. For 4 volts we have 0.33 milliampere. For 6 volts we have 0.50 milliampere. For 8 volts we have 0.67 milliampere. And for 10 volts we have 0.83 milliampere. Now what we are going to do is to draw a graph of voltage and current. For that we will go to Insert, Pivot Chart, click OK. We will move our chart to New Sheet so it's clear. Now here we put our current to y-axis and voltage to x-axis. We shrink the graph for making visibility clear and change the chart type to line. Now you can see that the graph is straight line. Here we have our voltages on the y-axis 0, 2, 4, 6, 8, 10 and 12, while we have current drop on our x-axis. So the Ohm's law is well verified and we have a straight line showing that voltage is directly proportional to current. Here I have placed the values with the graph. For 2 volts 166.67 milliampere, which is right here. For 4 volts 333.33 milliampere, which is right here. For 6 volts it's 500 milliampere. For 8 volts it's 666.67 milliampere, and for 10 volts it's 833.33 milliampere. So here is its graph. However, here I have shown the current on y-axis and the voltage on x-axis to verify that it don't depends on whichever quantity we take on the axis. The resultant graph will be a straight line. As I already mentioned, here Ohm's law is verified that with the rise in voltage, current also rises, keeping resistance constant. The direct relationship of Ohm's law for voltage and current is verified by straight line, that is V is directly proportional to I. Now that we are done with theoretical calculations and verification, we move to our Falstad simulator and do the required simulations for the study of Ohm's law. Here we are at the Falstad simulator. We go to circuit and check on the blank circuit to clear the screen. Now we will start composing our circuit having 4 resistors. So we go to draw and click on the add resistor. We place our first resistor, then we place 2 other resistors, now we will change the values. First resistor was of 6 ohm, second resistor was of 8 ohm, third resistor was of 4 ohm, and final resistor was of 12 ohm. Now we will connect the circuit through wires. So we go to draw and add wires. Here we have connected the whole circuit. Now we will place another wire here so that we may connect our power supply here. As it is already clear that we need to verify Ohm's law for the R equivalent of the circuit, so we first connect our ohm meter at this place so that we are able to know the R equivalent of the circuit. So we go to edit, outputs and labels, and click on ohm meter. We will connect the ohm meter. Here we have R is equal to 12 ohm. So we have 12 ohm R equivalent, and it is the same as that we got during our calculation. How? 8 ohm resistor and 4 ohm resistor are in series, so it's 12 ohm, which is then in parallel with the other 12 ohm resistor. So its calculation is 6 ohms. Now 6 ohms and this 6 ohms are in series, so the R equivalent of the circuit is 12 ohm. Now what we will do is to go to circuits and clear the blank circuit. We will start composing our circuit again. We go to draw, add resistor. We will place only one resistor having value of 12 ohms. Now we will go to draw, input and sources, and place a 2 terminal voltage source. Now we will connect the circuit through wires. Here our circuit is complete now, but we will add a ground so that our circuit is complete and all values that we get is correct. Now the yellow dots here are showing the path of current, and the green line is showing the path of voltage. As already conveyed, we have to verify Ohm's law by applying different voltages from 2 volts till 12 volts. So we will start applying 2 volts first. We will place 2 volts here. Click OK. Now we will click here. So here we have current as 166.667 milliampere, which is exactly the same that we got during our calculation. We again click here and change the voltage to 4 volts, and again check, and now we have our voltage as 4 volts and current as 333.333 milliampere. Again we change our voltage. Now we make it 6, and now again we check how much we got. We have current as 500 milliampere and voltage drop as 6 volts. Now we move our voltage to 8, and then see, here we have 666.667 milliampere current and voltage drop as 8 volts. Finally we check the parameters at 10 volts. Now here we have 833.333 milliampere of current and voltage drop of 10 volts. So these calculations are exactly the same as that we got during our calculation. Now there is another way to verify the values of current. For that we can connect an ammeter right here. So we delete this wire and we go to draw, output and labels, and put ammeter right here. Now here we have applied 10 volts, so we get 833.333 milliampere of current. We will go vice versa for the voltage. So we now apply voltage of 8 volts and check how much current we have. 666.667 milliampere. Now again we change our voltage to 6 volts and see we have current of 500 milliampere. Then we will check for 4 volts. We have 333.333 milliampere. And finally for 2 volts we have current as 166.667 milliampere. So the values are once again verified to be exactly the same that we get our calculation. So let's move and plot these values once again so that we are able to verify whether we have a direct relationship for voltage and current or not. The simulation have proven that for 2 volts we get 166.67 milliampere. For 4 volts we get 333.33 milliampere. For 6 volt we get 500 milliampere. For 8 volt we get 666.67 milliampere. And for 10 volts we get 833.33 milliampere. So when we plot it, we get a straight line proving the direct relationship of current and voltage. That is, with an increase in voltage we have increase in current. Hence Ohm law is verified. Now that we are done with simulations as well as theoretical aspects of Ohm's law, it's now time for your home task. As conveyed to you during the lecture that you have to find voltage for the values of resistor and current of example in slide number 4. You have to verify Ohm law for the given circuit and draw a graph of V versus I. You need to apply the voltages from 3 volts to 18 volts. You have to verify calculations through simulations. This is the circuit. I have already mentioned the voltages, that is from 3 volts till 18 volts, and you need to verify Ohm's law for R equivalent of these resistors. So best of luck. This was all about today's lecture. If you feel any difficulties or have any questions, you can ask directly through email or post it here. See you in the next lecture.